Clustering is a method from unsupervised machine learning. Unlike classification, clustering is used when we don't know the group labels in advance. Instead, we let the data itself reveal hidden structures, groups, or patterns. For example, imagine grouping customers only by income. Do customers earning $10,000 behave differently from those earning $11,000? Not always. Other factors like age, occupation, or household income matter. That's where clustering shines, finding natural groupings we might not see directly. There are two major approaches. Centroid-based, where each cluster has a center point, a kind of average member. Density-based, where clusters form based on areas with many points, packed closely together. Before clustering, data must be prepared. We check that it's numeric and we put all variables on the same scale. Otherwise, one factor like income can dominate results. Normalization methods like unity scaling or z-scores ensure fairness. K-means is one of the most widely used clustering algorithms. It starts by randomly selecting cluster centers, then iteratively refines them until points are grouped around centroids. The user sets the number of clusters k. But how do we choose k? The elbow method helps. We plot the clustering error against the number of clusters. At first, adding clusters reduces the error significantly. But after a point, the benefit levels off. That elbow suggests the best number of clusters. Another approach is the silhouette score. It compares how close a point is to its own cluster versus other clusters. A score near +1 means a well-clustered point, while scores near 0 or negative suggest poor clustering. dbScan is a density-based method. It doesn't need the number of clusters in advance. Instead, it groups points based on density. Points in dense areas form clusters, while sparse points are treated as noise or outliers. This makes dbScan especially useful when clusters are irregularly shaped or noisy. Clustering is often the first step in data analysis. Whether through k-means, dbScan, or other methods, clustering reveals hidden structures in data. Applications range from medicine to customer behavior analysis and even IoT data interpretation.